Yeah, ready for me? All right. Good morning, everybody from Quito, Ecuador, where I am based. Good evening, good afternoon, good whatever part of the day it is for you, wherever you are. We're just waking up here on our side, but that's not going to stop us. It's not going to stop us. We're going to try to pull our brains together and do a nice demo for you of the latest version of Sepal. Thanks so much for taking the time out to join us. Um, yeah, I have a short presentation to start with, just to bring us all up to speed or get us all on the same page, and then a live demo of the platform, and then we'll leave time for questions and any sort of discussion at the end. So, Maria, I'm ready to go with a presentation. If you have to be the one that allows me to share my screen with people. Or do I
Yeah, I
do
can
that?
do that. Yeah. Let us take us there. So just to looking at the chats, who is here? Okay, so we have about over half of the people haven't never used Sepal, so that's a good indication that probably we need to introduce a little bit also to the participants. We have a lot of participants from Africa, America, and Europe. I'm just opening now your demonstration place. So feel free to share your
Yeah,
screen,
just
Eric.
share my screen. You can see, hopefully, my messy screen.
Yeah, it's coming there. Yeah, a couple of seconds.
Okay. Well, in the meantime, let me know when it's visible for you, Maria. In the meantime, I just want to tell everybody that yeah, my name is Eric Lindquist. I'm the lead technical officer of the CEPOL program, and me and a bunch of other wonderful people are responsible for creating and developing and maintaining the platform. And yeah, I guess that's about it. Been working at FAO for about 10 years, 11 years, 10 years. Can't remember exactly, but was based in Rome for a long time, and now I'm based in Ecuador for a bit. Can you see the screen now?
Unfortunately not. It takes sometimes can take a little while.
Let me just make sure that I've done, oh, desktop share.
Okay, here we go, Eric. So the screen is visible now. It's okay.
Okay. So I promise I won't spend too long doing a presentation, but I thought that for people that have not used SQL before, that we should start out at least on a common base. So this is our presentation, SQL 2.1, a webinar. There was some debate whether we call it SQL 3 or SQL 2.1, and we've called it both. So we're going with SQL 2.1 for now, and we'll see how that goes. First off, yeah, just give a tiny presentation, then we'll do a live demo, and then we'll wrap it up. I must thank the CEPL team, all of the people that lend direct support, and all the other types of support that are required to run a team at the FAO. So thanks to all of them, and thanks also to our major donor, the government of Norway, and also the governments of Germany and Finland, the European Commission, and a bunch of other people, also to Google and all of our supporting cast of technologists and governments and whatnot. The main point I want to say, and some people, if you've heard me speak before, you've heard this from me before. This is that now is a good time for Earth observation. We have more data at hand than we have ever had in at any point in the past for Earth observation, and which makes it fun for us, makes our job really exciting. However, the challenge remains, and it always has been, is to make the best use of that data available to be able to do the most efficient analyses, the most effective analyses in relatively short time frames. So how do we do that? How do we meet that challenge with all of the data that we have available? Well, at FAO anyway, our teams within FAO, the CEPL team, and also basically the entire open forest initiative and all the people contributing to the open forest initiative, we have decided that through building these platforms and building these tools and open source tools and platforms that we can basically capitalize on this moment of data richness and use this as a time to catalyze the autonomous gathering of information, the autonomous analysis of that information, and hopefully improve decision making. When I say autonomous, that means that basically we want you out there, the users of the platform and the tools, to be able to do the analyses you want to do yourselves and not rely on others to do those analyses or to provide you with data that we want you to be able to show what you can do and provide that information yourselves. So the main objective of the Sepal platform specifically is to improve data access, to improve the processing of those data, and to improve the delivery of satellite data information products to the people that need it, to enable autonomous land monitoring capacity. So what is Sepal? Sepal is a cloud-based platform, and we use it as a catalyst for, as I said before, this autonomous land monitoring. It is completely open source. All of our code is available on GitHub. You can look at it, copy it, modify it, distribute it, do whatever you need to do with it. It's completely open source and free to use. And of course, at its heart, it provides the easy query, access, and processing of Earth observation data. In the guts of Sepal, we rely on many open source softwares that have come before us, not least of which is the Open Forest suite of software. We rely heavily on Google Earth Engine for some parts of our processing. We'll show that in a minute. We rely heavily also on the R statistical computing software, on Python, on Orfeo Toolbox, and on GDAL, for instance. So all of these are open source tools that are available out there in the world, but that we've combined them all together and made them easy for you to use without too much hassle. What do we want to do? What's our goal? Our goal is to, there's several. One, we want to reduce the time it takes from innovation or from coming up with a good idea with respect to processing satellite data to adoption of that idea on a global scale or on an operational scale. That is to say that if somebody has a really good algorithm or somebody has achieved really good results somewhere with doing something, we feel like we built a platform that allows that user to share their method quickly around the world in places that really affect change, where people make decisions. That is at the level of the ministry or wherever policy is made and decisions are made. We can get those innovations quickly out there. We want the platform to remove the fear of making mistakes, to enable fast failures, basically, because it's oftentimes through trying and failing that we come up with the solution. In the past, failing used to take quite a long time because of the download of data and the processing of data. Now, with the modern geospatial infrastructures and the vast amount of data available, we can fail in minutes or seconds. And all of those failures, if you build a place where those failures are safe and don't cost you anything, all of those failures allow you to reach the decision reach the endpoint a lot more quicker, reach a solution a lot more quickly. We want to enable collaboration in a common platform that enables, if I understand it, you understand it, and that person across the world understands it and can use it. And we want people to be able to collaborate in this space using, of course, supercomputing power in the cloud. We feel like our platform breaks down a lot of these barriers that had existed before to accessing analysis-ready data, to accessing supercomputers. We'll see how we can access supercomputers on our desktop from anywhere in the world using the Sepal platform, turn them on when we need them, and turn them off when we don't. And we're trying to remove the barriers to maintenance and dependency maintenance of both hardware systems and software, so that when you go to the Sepal platform, everything is up to date, most often. Everything's up to date and it just works. So you do not have to rely on maintaining these software systems yourself. We can also improve training consistency. So oftentimes with Sepal, we're running multiple trainings across the world on the same platform at the same time. And it's pretty exciting. Like I know just yesterday I was in Nicaragua with running a training in Nicaragua, and I know that's going on today in addition to all of the work that we're doing with the webinar. And we can do this all on the same platform across all the continents and all the time zones in the world, all in a similar way. And of course, probably most importantly, we want to make sure that we fit into existing processing methods. We don't want to be a replacement necessarily for something that works for you. We want to enhance what works for you. So you can jump in and out of the Sepal platform at any point along your processing methodology. If it makes something easier for you, we want you to use it, or we hope that you use it. If it makes something more complicated for you, then by all means, keep on with what you've got that works for you. And this is not a replacement for things that you already do. It's meant to be an enhancement. So that's really all I have by way of an introduction to the platform. I'd like to talk now, I guess, go right into the live demo because we have like 40 minutes for that. So I do hope you have your favorite beverage of choice. Mine is coffee, and we can go and do this together. The first part, if I can break it down into little sections, the first part will be called Sepal, Google Earth Engine, and You, which is sort of explaining how we work between the Sepal interface, the Google Earth Engine platform, and your user credentials. Then we'll show quickly then we'll show probably in depth a bit the Sepal process interface, how we create optical mosaics, radar mosaics, and supervised classifications in the new platform. And then we'll touch probably briefly on the Sepal applications interface. These are apps built in Python and R that are running outside of the Google Earth Engine. And then we'll talk finally at the end a bit about user resources and what that means for you and how we deal with that. And then it will be, in fact, the end. So let's go to the demo, if that's all right. And this is our website, of course, sepal.io. If I go to sepal.io, I will shut down one of my sepal.ios. If I go to sepal.io, well, typically you're met with a login screen, so let's go there first. If you have a username and password, you can sign in here. If you don't have a username and password, you can sign up for access, and you will be sent a username and password. Probably most importantly, if you think somewhere back in your brain that you signed up for Sepal at one point but cannot remember your password, please, you do not need to sign up again, but you can just click here, Forgot Password. You will be asked for your email, and a new password will be sent to you. Why is Adobe Connect yelling at me? Okay. Let's see, where are we here? Right, so then we log in. We do have versions available in the new interface. We have versions available in French, and the Spanish version is coming soon. So if you speak French or Spanish, that will be good for you. When we first log in, we start with what we call our recipe page, and these are things that we have saved, recipes or ways of creating data that we have saved from past sessions that if we want to recall these things, we can recall them now. If you're a new user to the Sepal platform, you will have none of these things here, and we'll have basically a blank screen with some buttons on the left and a few buttons on the right. The first thing we want to do, usually, is make data, right? So that's usually why we're here. So the first thing we want to do is go to the process button in the upper left corner of the screen. And we want to typically create a new process with the green button on the bottom right. When we create a new process, we are given the option of which kind of process we want to create. We can create an optical mosaic. This is using freely available Landsat and Sentinel-2 data, Landsat from the USGS and Sentinel-2 from the European Space Agency, of course. We can create a radar mosaic. This, at the moment, is Sentinel-1 data. We are working on the ability to create ALOS pulsar mosaics, but right now Sentinel-1 are the data we have available there. We can create a classification if we have data. If we have recipes saved, we can use those recipes in a classification. And if we want to create a time series of data, we can create a time series here. So these are the 4 options we have right at the beginning. Let's start with an optical mosaic. If I create an optical mosaic, I am prompted for three things. I need an area of interest, I need dates of interest, and I need sources of interest. That is to say, I need a place where I want to create a mosaic, I need a time period for which I want to create that mosaic, and I can select the data sources I want to include in that mosaic. So let's see, first things first. Just for an example, let's select a country. I was working on this yesterday, so let me see if it works today. I can go to any country in the world. Let me see, let's go to Nicaragua, where I was yesterday. Nicaragua. And I click on Next. If I click on the year, I can decide which year I want to create a composite or mosaic for. This goes all the way back to basically the beginning of the Landsat archive, which is in the early 1980s. Data was scarce for some regions in the early 1980s, so it may not exist for everywhere. If I select the year for 2018, let's say, I can go click Next quickly, and then I'm asked to give the inputs, like which Landsat sensors do I want to use, or which Sentinel sensors do I want to use. I can start with Landsat 8. I can Landsat has been divided into two collections, or several collections and several tiers, with collection 1 data, tier 1 data being the highest quality data in the Landsat archive, and collection 1 tier 2 data being the next highest level. We don't use so we only use collection 1, tier 1, and tier 2 data in the system. We do not use collection 2 data. That's just sort of a technical aside there. We can see what's available with Landsat 8, and then if that's all we want to see, like what is the best composite we can do with Landsat 8, I'll just click Done, and it will generate the best composite possible with Landsat 8 collection 1 tier 1 data in 2018. So this is sort of the quick and easy 3 clicks and you're done. If you just want to make the best thing you can make for any one year, you can, with 3 clicks of the mouse, you basically are able to do that. Now, of course, we've hidden a lot of the detail. There's much more to do with mosaics to make the best mosaic possible, and we've hidden a lot of that, so it's only available if you want it. This is Nicaragua. We can see that even with only Landsat 8 collection 1 tier 1 data, we have a lot of cloud contamination in our composite. So let's see, we want to change the source and add more data. So I will add Landsat 7. I will add all the Landsat 8 tier 2 data and Landsat 7 tier 2 data and apply that. While that's going, I can look at some of the other options we have. We can select scenes by hand, for instance. So if we know the scenes we want, or if we want to be very particular about which scenes we select, if we're only dealing with one type of data here, so only Landsat or only Sentinel-2 data, we can select scenes automatically, or we'll select scenes by hand as to which scene is the best for us. I think I will skip over that now, but it's there if you need it. Also, we have some composite functions. We can configure the composite functions, and this is a way for us to show you which pre-processing methods we're applying so that you don't have to, and you can make the best available data. So just by default, we are converting all of the values, the Landsat values, to surface reflectance. When these buttons are lit up in I guess that's sort of an orangey color, that means that correction is applied. If I turn it off, it goes to gray, and that correction is not applied. So we do automatically apply surface reflectance, and we do automatically apply a BRDF correction. which is a correction that makes that corrects for the angles between the sun, the ground, and the sensor, which can cause issues in automated classifications. It's a fascinating thing that I can let you read about on your own. And then we choose whether we want to apply a cloud mask. If we apply a cloud mask, we can buffer that mask to filter out even more clouds. We can apply a snow mask if that's an issue for us in our location. In Nicaragua, they do not have a problem with snow, so I will turn the snow mask off. And then we can choose whether we want to select a real pixel. This is the medoid, which is the pixel closest to, in value, closest to all of these parameters that we can set, or the median, which is a calculated value, and it calculates the median value of all the pixels available in the stack for us. The medoid is nice because it comes with a date attached, so we can track the date of the pixel. If we use the median, we lose that date information, and that could be very important for us, the date information. So typically in applications for red monitoring, for MRV, we need the date information for that pixel, and we leave the medoid, and then I can apply that. And so those are applying all of those pre-processing algorithms automatically. Those are applied by default, so you don't really have to know what they are, but if you do want to be in more control, you can control them even more. And that's going to draw up with any luck. This part we're relying for the composite generation, mosaic generation, we're relying heavily on the Google Earth Engine to do this. So through the Sepal interface, you are sending commands, sending parameters to the Google Earth Engine in the background. The Earth Engine is running, and the screen, the result that you see on your screen is the result from Google Earth Engine. We make it easier to manipulate the Earth Engine the way we think it should be, or the way we think it should be manipulated. And we can see that even with all of the Landsat data available to us, this is every Landsat pixel, so all the acquisitions for one year, we still have cloudy areas in Nicaragua. I will say that we have the ability to add now Sentinel-2 data to this composite if we want, this mosaic if we want. So we can create a combined Landsat Sentinel-2 composite just by clicking on A and B right here. That's going to add all the Sentinel-2 data available for 2018 to our composite and combine it properly with the Landsat data. If we just want a Sentinel-2 composite, for instance, we can turn off all of the Landsat sensors, and this will be just considering a Sentinel-2 composite. So depending on the needs we have, we can do Landsat only, Sentinel-2 only, or a combined composite of both of them. I will just keep on with the Landsat because of time constraints. But of course, the difference between Landsat and Sentinel-2, Sentinel-2 has a finer spatial resolution. Some bands of Sentinel-2 are 10-meter spatial resolution, and some are 20, whereas Landsat has a spatial resolution of about 30 meters. So depending on what's important for you and your monitoring, that may dictate the kind of data you want to use. Yeah. So when I have a composite that I'm happy with, I can save this composite as what we call recipes. So a recipe is not saving all of the data itself. It's saving the method used to create the data. So that means we don't have to save a lot of heavy data, but we can save the way that the parameters used to construct the composite, and those we can recreate at any time. We can also export our recipes, and we're working on the ability to share recipes between users. So all I have to do is give the recipe a name here in the upper right, and I'll just call that Nicaragua 2018 L8 L7 T1, T2. So for me, this is a name that you can specify. For me, it tells me that I've made a composite. This recipe represents a composite of Nicaragua in 2018 with the Landsat 8, the Landsat 7, and Tier 1, Tier 2 data. And when I hit enter, that recipe then is saved. And if I ever want to recall that recipe, I can return back to the process button, or I can add a new window, actually, and I can see that I have saved this recipe as Nicaragua 2018. It's an optical mosaic, and if I want to recall it, I can simply click on the button, or click on the line, and it will recall that recipe, and I have that recipe to use again. Recipes we'll see are important because we can use recipes in classifications and change detection and all that kind of stuff later. So next thing I want to do is show you quickly how to make a Sentinel-1 radar mosaic, because I think that's probably of interest to a lot of people, and it's something that's been difficult to do in the past. So if I want to make a and select radar mosaic. This time again, it's the same functionality. I can select a country, or I can select a fusion table. If we have our own shapefiles, I should mention that if we have our own shapefiles that we want for an area, we can convert those shapefiles into a fusion table and use that fusion table to create a zone of interest that's of interest to us only. I realize that Fusion Tables is going away in December, but do not panic. We will panic for you, and we are panicking a little bit, but we have on good word that Google Sheets will replace Google Fusion Tables, and we are working on the fix for that. So come December, when Fusion Tables goes away, it will be hopefully seamlessly replaced by Google Sheets, and the same process will, so basically for the users of the platform, the process will be seamless. So let's Nicaragua, that's all we need. Then for Sentinel-1, we can enter a year. That is to say, we will use all the acquisitions available from Sentinel-1 in a year. We can enter a date range, which should be over multiple years, or we can enter a specific date, in which case we just get one return back. Depending on whether we enter a year, a date range, or a date, the data we return back with is different. A year means that we're using all of the data acquisitions available within a given year. So what is returned to us are annual metrics of the Sentinel-1 sensor. What is an annual metric? An annual metric is things like the maximum return from the vertical band, or the maximum return from the vertical horizontal band, the VV or the VH band, the minimum return, the median return, the standard deviation, that kind of thing. All of those information, all of those types of data we can use if our analysis calls for that to determine things about the landscape. At its most simple, that's all I need to do, just an AOI, an area of interest, and a date for the Sentinel-1 data, and the return will be a Sentinel-1 radar composite over our area of interest, represented by those metrics. We can see those metrics, the metrics that are being displayed in the red, green, blue color space of our monitor down here on the bottom. If I want to change those metrics, I can, and this works the same for optical data, I can change the bands that are being displayed in our monitor just by clicking on another option here. So if I want to change the bands, I can use that to do it. And you can see that you get a pretty stunning image back from the Sentinel-1 sensor. Whether or not, to what degree it helps us depends on our analysis, but if we want to incorporate radar into our analysis, this makes it easy to do it. I should show that this is the optical mosaic over Nicaragua. If I want to change the bands on display, I can click there at the bottom with the red, green, blue and change the color combination if that is of interest for me. So there it is in its most simple form. For Sentinel-1, we have some options that you can change. You can change whether you consider an ascending or descending orbit. You can change the corrections applied. You can change the filters applied. There are a couple basic filters here that are used frequently in radar processing and may or may not be of assistance to you. And then you can choose the outlier removal, which helps reduce some of the noise in the radar signal, if that's something you want to do. And again, all of this is designed so even if you don't know much about radar processing, you can try all of these things until you get a result that you like, and it happens in a matter of minutes, and so you're not wasting time trying things that in the end don't help you, but you can decide whether it helps you or not. Let's see, 7:30. So let's move on. I'd like to show you quickly how we use some of these things in a classification, because I think this is probably of interest to most people. Like, how do we create our data? We create our data for a purpose. That purpose is often for classification or change detection, which is also, of course, a type of classification. So let's move to a classification. I will open a new window. And all of these things can be opened at the same time. It's not hurting you. This is something new with the new interface that makes it much easier to work. Oh, I forgot. If I want to save this, I want to save this radar recipe. I will call this Nicaragua 2018 Sentinel. I would usually call it S1, but Sentinel-1. There. So now I have the recipe. I can recall that recipe at any time. So classification. If I want to classify things, I go to the new tab here and open a new process again. And this time I want to open a classification. Classifications the classification interface is pretty simple. We just need to add the data we want to use in our classification in the box in the bottom right. That is fairly straightforward. You just click on the add button. There are two options we have of, I forgot the very first part of the presentation, didn't I? Earth Engine, Sepal, Earth Engine, and you. I'll get to that in a second. Sorry. Give me 2 seconds. That's the 7:30 a.m. Brain. Anyway, so we have two choices for working with data in classifications. We can add a saved Sepal recipe. So those are the things we just created by saving the construction of the composites and mosaics, or we can add an Earth Engine asset. I will show you right now how that works, because this is important and it's something I completely forgot right at the beginning. So Sepal speaks with Google Earth Engine, and we do that on purpose because Google Earth Engine is a very efficient way to process and store geographic data. In the portion of the Sepal interface that allows you to manage your user profile, that is the bottom of the right-hand screen where you see your username. If you click on the username, you will see your name, your email, the organization from which you come, and you will see a button here that says either use Sepal's Google account or use my Google account. We have the ability to change the way Sepal and Google Earth Engine interact. Typically, step 1, which I forgot, is to link your Sepal account with your Google Earth Engine account. If you do not have a Google Earth Engine account, we recommend that you sign up for a Google Earth Engine account. It enables many more things in the Sepal interface that make your life easier. I will show you how that works. Typically, when you're a new user to the platform, you will come in and see this, and it will say use my own Google account. And if I click on that, I am now switching from using Sepal's account to using my own Earth Engine account. I have my Earth Engine account listed under my Gmail. I can click on the Gmail. I can allow Earth Engine to access my my Gmail, my Google Drive files, and all of that is good. So now I'm connected. My Sepal interface is connected with my Earth Engine account, and I can do some things that I couldn't do before. Let's go back, add a classification, which is what I was doing before. Add a classification, add data to the classification. Again, I can add Earth Engine assets, or I can add a saved Sepal recipe. In this case, I will add a saved Sepal recipe because I just saved some recipes. I have already created a recipe for an area over the Republic of Congo. I'm going to use that recipe that I have. When I enter that recipe, I can see the bands. I should be able to see the bands for that recipe appear. That's not happening. It should load the available bands, but it's not right now. So let's see what happens when I go to the Nicaragua mosaics I just made. So if I have Nicaragua, okay, that's good. Sometimes if things aren't going right, you can click on the refresh and try it again. I would like to go to classification. Let's see if I can add the saved Sepal recipe. And I'll go to Congo. Let's see if that works this time. And no. Excellent. Okay. Well, let me cancel that. Let me see if I can recall a classification that I have done in the past. If I add a window, I can show you so I somehow switched. I'm going to change back to use my own Google account again. Just to allow that to happen. If I go again to the mosaics, I can show you the mosaics. The one thing I wanted to show you too while I'm talking about this, once we create a recipe, we can save that recipe in a number of ways. So we save the recipe, but we can also then download those data to one of two places. We can download the data to our Sepal workspace. So everybody, when they have a user account in Sepal, they're given some space in the Sepal cloud to store and process data. So we can download this data directly to our Sepal workspace, or, and this is one of the main reasons we link our accounts with the Google Earth Engine, is we can download data directly into Google Earth Engine as a Google Earth Engine asset. Google Earth Engine assets are things that we control. They're our data. That's something that we've customized, that we've made, and we can save them in Google Earth Engine as an asset and use those data to process within the Earth Engine. This is an example of the Sentinel-1 data, and all of the bands that we have available are, well, they're numerous. So these are all of the annual metrics that are able to be generated by Sentinel-1 data. And I can select which bands I want to save and save those bands. I can adjust the scale of the data. This is important, especially if I'm including Sentinel-1 data in a classification along with, say, Landsat or Sentinel-2 data. I want to make sure that the scale of my Sentinel-1 data is at a similar scale. So if I'm using Sentinel-1 data in a classification with Landsat, I will change the scale to match that of Landsat and do 30 meters. So this is going to output, this will save the Sentinel-1 composite with 30-meter pixel size. As I said before, I can download this to the Sepal workspace, or I can download this as a Google Earth Engine asset. Typically, I want to, well, depending on the need, I can where I download these data is purely depending on the need, whether it's Sepal workspace or Google Earth Engine asset. And the nice thing about this is that none of these downloads depend on your local internet connection. These are downloads that are occurring between clouds, between computers in the cloud. And I can start a download if I retrieve that asset. So now I'm retrieving the asset I'm retrieving the Sentinel-1 composite as a Google Earth Engine asset. I can see if I go then over to the left-hand side of the screen, there is a tasks button, and that tasks button is spinning, indicating that I am exporting. I can see that I am exporting a composite into Google Earth Engine as an asset. Now, I can shut my computer down at this point. I can go home for the day, and this download will continue no matter what, unless of course there's some other issue with the download. But if there's no issue with anything, this does not depend anymore on my connection, my internet connection. It will download directly to Google as an Earth Engine asset and will be available in my Earth Engine assets folder. I should mention that if you have not used Google Earth Engine before and you try to download as an asset, you will need to first go into Google Earth Engine and enable an assets folder to be created. Basically, that just means starting up a session of Google Earth Engine, and that asset folder will then become available. If you haven't started Google Earth Engine ever in the past, that asset directory is not made available, and this does not work. So you need to open Earth Engine first. So while that's downloading, I can do anything else. I can do anything else I want. I will try again to see if a classification is possible. Should be. Let's see if it works this time. I'm going to go back to, let's see, I have a Congo L7, L8 classification, and it should load the available bands. Yes, it did. So now I can see the bands of the recipe that I had made earlier. So I have a shortwave band, a near band, a SWIR band, a thermal band, and of course the optical bands of blue, green, and red. Something very cool that we've implemented in the new platform here are derived bands. So we make it easy for you to include ratio bands, normalized difference bands. If I click on normalized difference bands, I can choose which bands for which I want to create a normalized difference. And these are all customizable. If I want to include simple difference, I can do that, or spectral distance, or spectral angle, or any indices. These are the indices we have available. And I can automatically create those indices and add those indices into my classification stack. Also, we have our basically pre-compiled, again, profiles of classification schemes. So we work together with Silva Carbon, together with NASA Surveyor, and they are, NASA Surveyor especially is using this thing they call the Regional Land Cover Monitoring System. That comes by itself with a set of bands that are always used, and I'm going to click on that, and automatically I populate the list of commands with, or the classification stack with these bands, and I can apply that. And then I can click next. We have training data. We can create training data in any number of ways. We can import field-based data. We can create training data in Collect Earth or Collect Earth Online. Or we have a training data collection tool with inside Sepal that you can use if you have no training data available already. Here we enter a fusion table. Again, this will be Google Sheets in the future. And that fusion table will then contain 2 columns at least, one with coordinates and one with class. If you have those data ready, a classification is then run automatically. You can add auxiliary data to the classification here with terrain and other things. I have a classification which should already be done. This is something I did earlier just to show you. So we used field data collected by the CNIAF in the Republic of Congo, applied that to a satellite mosaic, and have come up with a classification, which should appear down here in the Congo. I realize I have about 5 more minutes of the demonstration, so unfortunately I can't touch on everything I'd like to touch on, but just to say that you can combine all of these data. You can combine the Landsat with the Sentinel, with the Sentinel-1 radar, put it all in a classification, add training data to that classification, and run that classification. We have auxiliary data, like I said here, if latitude, terrain, or water is important for that classification. Those are things we can add and include as layers in the classifier. We run a random forest classifier. That's the only option we have right now, but we are working on adding more. So real quickly before the end of the presentation, I want to show you the user apps part of or the Sepal apps part of the interface. So if I click on the wrench tool here, I'm taken to Sepal apps. Now Sepal apps run outside of the Google Earth Engine. So these are things that we develop in R or Python, and things that we can run and customize. Run and customize on the platform. We have access to RStudio, Jupyter Notebooks, Jupyter Labs, and these are tools we have made ahead of time so that just run and take you through step by step the processes you need to do. So stratified area estimation, design and analysis. We have time series analysis. If you download a time series from Sepal, you can process that using the BFAST algorithm. And we have various other tools that you can try. This is a plot generator for field sampling design and other things. All of these things run, and you can give them a try at your leisure. If you have RStudio code, for instance, you can run your code on the computing system. And these are all very exciting and fun to customize. Supercomputers. Get to that in the 2 minutes I have left. If you go to the terminal, so this is now the Linux command line terminal of the Sepal interface, you will see the initial time you go, you have access to a range of supercomputers. Now each of these computers then is a computer available in the Amazon Compute Cloud, but this could be any compute cloud. We just use Amazon right now. And you can access any of these computers and run whatever process you're running on these computers. You will see, however, that, so I can start, let's see, a number 2, which is an M3 medium, which is a 1 CPU, 4 gigabyte machine. I have access all the way up to a 128 CPU with 2 terabytes of RAM, and I can start a machine. You can see, however, that each of these machines uses some amount of money. Now this money is money that our project supports, and it supports it for all the users of the Sepal platform. So as we start a computer, you start to use what are called your user resources. Every user is given, every user of the Sepal platform is given a basic amount of resources to start, and then as you use your resources, you are given more resources as you go. This is your user account. And you can see the quota, the instance budget of your quota, the storage budget, and the amount of storage you have available to you. And as I said, as you use more, you get more, because we start everybody out with a very small amount to see who's interested in using it, and then we go up from there. Just to say that you start these computers and you can run any of these app processes on the supercomputer you start up. So that will help you in your computing issues if you need to do something over a large area or have something that runs that's very complicated. You can do it there. And that is 7:50. That is my 40 minutes of demo, and I will stop my presentation at this point and ask if there are any questions or any discussion for the last 10 minutes. And thank you very much for your attention.
All right, so we have already quite a few questions here for Eric. So we agreed, Eric, you can manage this. So Yelena and Remy have been helping to choose some questions for you.
Selected questions, right? So for those of you who have used Sepal, a quick summary of what's new would be helpful, right? What's new? What's new is the way is of course the ease with which we do Sentinel-1 composites, the ease with which we do classifications. All of that stuff is new in the new platform. I should mention that the new platform runs on mobile devices or tablet devices, all the same. So if you want to run and create composites on your mobile phones or tablets, you can do that. Some of the R Shiny applications are not so tablet friendly or mobile friendly yet, but we are working on that. The access to combined mosaics is new in the new platform, so creating a new combined Sentinel-1, Sentinel-2, or Sentinel-2 Landsat is all new in this new platform, as well as there's a lot of things going on behind the scenes that you don't see, speed ups in all of the processing, speed ups, the ability to run more than one app at one time, the ability to run more than one composite at one time, the ability to control the scale of your downloads, the types of bands you use in the classification, the way I showed that it's easy, immediate to make ratio bands and incorporate existing classification schemes in the classification and change detection. All in all, I mean, it's a much more efficient, much more smooth, much more powerful platform, I think. I hope that gets to that question. Question number 2, how big is the Sepal workspace? Your Sepal workspace starts out with 20 gigs of space, and we adjust from there. Typically, the idea behind the Sepal workspace is not that you use it as a long-term storage space, but that you bring data in, you process those data when you need to, and then download the product to your own computer, and then you delete the data that you have in your Sepal workspace. It's only there to facilitate the use of the supercomputing power on your data, to facilitate that analysis, and then allow you to download those data to your workspace, at which point you should get rid of the data in your Sepal workspace. So hopefully 20 gigs is enough, but of course we can modify that as we need. How long does it take to get Sepal access once I sign up? That's a good question. Well, this part of Sepal access is very manual. So when you sign up, it comes to a list that we curate basically, and then we by hand add your user to the list. Usually that is within the day, but sometimes it takes maybe another day extra for us to get to that. But it should be within the day or within a day that you should receive Sepal access. Where do you ask questions about Sepal? There are several places to ask questions about Sepal. We have a Sepal Google group that if you are signed up as a Sepal user, you will be invited to the Google group and you can ask questions there. You can email questions directly to us. And then there's also the Open Forest. There's an Open Forest wiki and discussion forum where you can ask questions as well, and we will provide a link to that Open Forest discussion forum. Is it possible to use RScript, and what is the cost of using the platform? It is possible to use RScript, yes. So if you have an RScript that runs, you can run RStudio and run that RScript on your data that you have in your workspace. The cost of using the platform varies depending on the cost of the instance, the computer you start up in the cloud. But of course, for you, for the user, the cost is nothing. It costs you nothing to run the platform. So yes, we would love it if you have a custom R script that does something cool. We would love it if you ran it in the platform and we could see how that works. One thing to be cautious about, I should say, when you're running on a supercomputer in the cloud is make sure your code can access all of the CPUs available in the supercomputer. Oftentimes, if you're developing code for one CPU and you try to run that code on a supercomputer with 64 CPUs, let's say, if the code isn't able to access those 64 CPUs, you'll only be running on one of the 64. So make sure you're aware of that when you start computers in the cloud. That your code also has to be able to access those CPUs. Number 5, let's see. How well do Landsat and Sentinel-2 combine into a consistent composite? They seem to combine very well right now. We of course convert those data to surface reflectance, so of course a common unit, so that we do not have to do much inter-sensor calibration there. They're all in reflectance units, and they combine well enough. And of course, they combine at the scale that you want. We typically combine those data at the 30-meter scale. When I don't download a product, does it come with its metadata? It does not come with its metadata in its sense that it does not come with all of the metadata of the Landsat, of an individual Landsat scene, of course, because we're combining a bunch of different products. But what it will come with is you can download with it the date of acquisition and the sensor of acquisition, so that you know that it comes for sure from what sensor and from what date. And generally that way you can trace it back to the individual granules of metadata for individual scenes. So between the composite and the recipe for making that composite, you have a pretty transparent system to show people what it is you've done and what you've used. What will be the replacement of Fusion tables? The replacement of Fusion tables will be Google Sheets, most likely. So that's what we're planning on, and that's what we're working to implement inside the platform. Let's see, number 8. I would like to map and calculate burn area for some areas in Mekong region for a period in the Sepal platform. Can you briefly share how this can be done? There are two immediate ways for that to be done. There are, of course, many ways for that to be done within the platform, but two immediate ways that come to mind. One would be, of course, creating a pre-burn mosaic, so using the date functionality within the mosaic creation tool, and create a mosaic of your area pre-fire or pre-burning season. Then make another composite of your area post-burn, so that you theoretically have captured that burn area within that time period. So the time period between the pre and post composites, and you should be then able to run a classification or a change detection in the classification part of Sepal to detect those burned areas. Another tool that we use a lot for detecting burn areas is the time series analysis. I didn't get a chance to really show that, but you can create a time series analysis that incorporates the period of burning in your composites, analyze that time series analysis with the BFAST time series algorithm, and the result will show you where there are strong positive, strong negative, or somewhere in between the magnitude of change over a full area. We're happy to help you with that in more detail if you want. Yeah, it's a cool application of it. How can you export the data and import in QGIS? Well, I showed just a little bit ago. You can download the data direct to your Sepal workspace, and then from your Sepal workspace, you can download the data direct to your computer, to your desktop or laptop. That is done in the toolbar on the left-hand side of the screen. There's a little file folder. If you go into the file folder, you can see the files you have available in your Sepal workspace, and then download those directly to your laptop or desktop and use them in QGIS.
Okay, Eric, now there's a good spot. So before we if people still have a couple of minutes to give us some feedback and guidance. What topics are you interested in? After that, we can revert back to the question and answers. Question and answers section.
Yeah, I have
And
all
yeah,
the availability. I'm available for however long you want to talk.
all right. This will be a long webinar. In the meantime, whilst everybody's typing in your feedback, suggestions, where you're working still, here's another opportunity to share your email as well. So just to summarize, we were at least 205 participants, excluding the organizers today online. A lot from Africa, many people from North America and Europe. Gender about 30%, sorry, female and 60% male participants. Just in a nutshell on who was here online. Yeah, I hand back over to you, Eric, or if Yelena and Remy, who've been busy selecting all your excellent questions, have something to say, please feel free.
Yeah, well, if nobody has anything else to really add, just thank you everybody for your attention. I hope it's clear. I know I didn't focus on maybe necessarily all the new things that the platform does, but I thought through showing you the way we do some of the things that we used to do with the old platform, that it's a bit of a different workflow and it's a bit more efficient, a bit more effective, I think. It's certainly more stable from a performance point of view, and that makes us happy, and hopefully you can try that. I should say that we are building immediately on our list of to-do things is develop tutorials and user manuals around the new interface, and that is something that we're doing the second half of this year, and those will be out very soon. A couple things one last thing I want to mention is that you may have heard the news that Norway is providing access to high spatial resolution data for all the countries, that they're going to purchase those data over the next 4 years. We expect those data to be available, I don't know, sometime late this year or maybe early next year. And we work closely with Norway, and of course those data will be accessible in the plan is for those data to be accessible in the Sepal platform and through some of the collector, the open forest tools, which is very exciting for us. Yeah. Thank you so much for all of your time and your patience. I really hope that you use the platform for some of the work that you're doing. I hope that you share your results with us. If you do something that if you do something, please feel free to share it with us, because we're always interested in seeing how the platform is being used around the world, and it makes us happy to know that if we've helped you in some way, or the platform or you're doing something cool with the platform that we haven't even imagined. I think it's fairly flexible to do that. And so, yeah, thank you for your attention from wherever it is you are. I sure appreciate it. And I know I speak on behalf of the Sepal team that they all do appreciate your help and your effort in this, and your work that you do. So thanks so much.
Yeah, thanks a lot also from my side. And just to let you know that the Sepal team here on the back end also were saying, like, you'll receive answers to your questions in a written format if we don't have time to reply everything now in the live session. I think many people need to log out soon, as we are already up over the hour reserved for this. Yeah, let's. I'll leave the webinar platform open now. So Eric, also, if you have still a little bit of time, of course, all the questions are there, and we could even make some space in this. As I see not many people are anymore voting. I'm just hiding one of these pods and putting back here the selected questions. One moment.
I already see one question additional that I can answer about are there follow-up trainings planned in the future? Yes, there are. I mean, the Sepal team is constantly working. We've got people working around the world in all the regions, delivering trainings at both the national scale, local scale, well, the national, local, and regional scale. We're happy to do whatever trainings we can in your region. If you're interested, we'll be happy to come and do whatever we can for you, or do more of these webinars as well over very specific topics. For instance, burn area detection, we could do something like that. We are also working, as I said, very closely with our partners, Silva Carbon, NASA Surveyor, and other partners around the world. And the idea is that together, and Google partners as well. And the idea is together between us, we can come up with a set of a more consolidated set of trainings, and that, you know, if you go to a Silva Carbon training, you're going to get some elements of what you might get also in an FAO training, and vice versa, and same with the NASA Surveyor, so that hopefully all of these things start to build to a sort of more of a, what would you say, a more collective whole. But yes, we are planning more trainings around the world, and we will keep you up to date on that.
All right, I think we are about to stop the recorded session here and wrapping up the official part, let's say. Many thanks, as Eric has already said. Thanks on behalf of all of us. We were so many online today and very active. So as said, you will receive the recording at the later stage. Thanks a lot, and also the responses to the remaining questions. Have a good day. Bye bye.